so good. What should be on your desk right now is the homework that was due on Monday from the textbook on arithmetic sequences. All right, it was page 674. Is everyone like cool? Cool. Okay, cool. All right, so good. Just to have a little bit of what's it called, continuity or something. Recall that we had two main achievements on Friday. We discovered the formula for the sum of the first n positive integers, and we discovered that that was n plus 1 over 2, yeah? Yeah. Good. And then we also, more generally, looked at sums of arithmetic sequences. So if I'm summing up a bunch of things and the first term is a, and the next term is a plus d, and the next term is a plus 2d, etc., and I keep going until I get to the nth term, and by the way, when I get to the nth term, how many times have I added d? Yeah, there's only one correct answer to that question. It's n minus 1. Because like to get to the second term, I add d1. To get to the third term, I've added d twice. So to get to the nth term, I've added dn minus 1 times. We proved via much exciting investigation that this is in fact n over 2 times the quantity 2 times the first term plus n minus 1d. Yeah? Say good. Good. Woo! Alright, then there were some relatively chill homework problems. Let's do a couple of them right now, and I can do different ones if you want me to. So this is page 674, I'm just turning to it right now. And one problem was 43. This is just straight up, like, nothing special problem. Here's what it said. It said, yo, take the following sequence, -6, -2, 2, 6, and find the sum. Also, this is an arithmetic sequence, and it said find the sum of the first 50 terms. Alright, so this is basically just pure mindless formula application. Yeah, I know that my first term is -6, and what is the difference here? Well, it's 4, yeah? So d is 4, and so probably what I would do is to just then use the formula. So then the sum of the first 50 terms must be 50 over 2 times twice the first term plus, and if I'm on term 50, then 49 times must I have added 4. Cool? Okay, and now like I just have these really big numbers, so that makes me kind of sad. What is that? Like 296 minus 12, 284. Someone back me up on that? No one's backing me up. Because it's like raw. 184. 49 times 4, right? Yeah. 196 minus 12, 184. So whatever that is. I'm too lazy to do 184 times 25. Anyway, that's the answer. Cool? Okay. Is everyone kind of remembering this a little bit? Let's do a couple more. That was 43. 55 was like still not very interesting problem, but like kind of maybe a little bit. It was, what's up?
I just wanted to ask you a super quick question.
What?
Not in front of that.
Okay, goodbye.
Okay.
All right.
Can you around after this for a
yeah,
while?
sure. So n equals 1 to 500 of n plus 3. Okay, I thought this was like a cool problem because, well, it's not a cool problem at all, let's be honest. It's a boring problem. But there's a couple different ways you could do it. One way you could do it is the I'm kind of scared of sigma notation way, so let's just like get the sigma notation out of my life as soon as possible. And if that's the case, then what is this really telling me? It's saying, okay, when n is 1, we're starting with 4, and then when n is 2, it's 5. When n is 3, it's 6. Okay, I think I see what's going on here. We're just adding up all the numbers from 4 and ending at when n is 500, which is just like 503, yeah?
Yeah.
Say yeah.
Yes.
And this is the 500th term. Of course, then I can just be like, okay, let me just use my formula, which says that the sum of the first 500 terms is 500 over 2 times twice the first term plus, and well, d is just 1 in this case, because duh, and I have added 1 499 times by the time I get to 503. That's like true, right? Yeah. So this is just 250 times 507. And then whatever that is, that's the answer. Okay, is that what you guys did? Okay, alternatively, you could, there's like another maybe way to do this, which is to, so here, if I'm adding 4 plus 5 plus, I'm adding 4 plus 5 plus 6 plus all the way up to 503, you could just be like, oh, this is just like pretty much the formula for the sum of the first n integers, but like missing a couple of numbers, right? It's like missing the 1, 2, 3. So you could just be like, oh, I'm just going to use the formula for the sum of the numbers up to 503, which is just n plus 1 over 2. So this is just 503 times 504 over 2 would be the sum of all the numbers up to 503, and then I just subtract out those first couple, which in this case is just 6. Cool. Even another way, this is the kind of I'm not scared of sigma notation way. So you have the sum from n equals 1 to 500 of things of the form n plus 3. You could like split this up into, okay, I'm adding n and 3, and n and 3, and n and 3. So really, I could think of that as just like adding n a bunch of times, and then adding 3 a bunch of times. So now I'm using like some kind of property of sigma notation, which says if I'm adding two numbers 500 times, then the order doesn't matter, so I could just add, the first one 500 times and then the second one 500 times. Follow?
Follow.
Okay, well, let's do them one at a time. This is just adding 3 literally 500 times, so that's just 3 times 500. And what is this? It's like 1 plus 2 plus all the way up to 500. Oh, I have the formula for that, right? This is just 500 times 501 over 2. So whatever that better be like the same thing. I think it is. How we doing? Yo.
Wait, is this function taking like every n and adding 3 to it for every output, or is it adding n plus 3 to every?
It's going, what? It's going through changing n by 1 every time.
And it starts at n plus 3. Okay.
No, it's what? It starts when n equals 1. Hold on, I'm going to talk to you later. Alright, good. Are we good? Good, okay. Then there was like maybe like one other cool problem that was like also not really cool. 64, but this is like a piece of vocab that we never did in class. It said insert k arithmetic means between the given pair of numbers 2 and 5. Okay, so what that is all about is like, yo, take the numbers 2 through 5 and insert 4 numbers in between them in such a way that the entire thing forms an arithmetic sequence. Did you guys all figure that out? Okay, so basically I need to add like d and then add d again and again and again and again. Well, that's like 5 d's I just did, right? Okay, so common sense says, all right, then I can calculate d by just setting up like a little equation. Okay, so that means d is like 3/5, yeah?
Yeah.
And that checks out because if 2 is 6/5, then if I add 3/5, I get 9/5. And then if I add 3/5 again, I get 12/5. I think I messed up.
Yeah.
Yeah.
Woo! Yeah, 2 is 10/5. Someone just informed me. So now if I'm adding 3/5 to 10/5, I get 13/5. Then 3/5 again is 16/5. 3/5 again is 19/5. 22/5, and then 25/5. So it all works out. Cool?
Cool.
All right. Good. All right. So now one like loose end or whatever that we didn't do. So this will be like the last. This is just like another thing you can do with arithmetic sequences. Here, I'm just gonna do it over here. Suppose I gave you a particular arithmetic sequence. So take the following arithmetic sequence. arithmetic sequence. Here is what it looks like. 3, 10, 17, 24, etc. And I now tell you that the sum of the first n terms is 279. Goal, find n. Go. It is a fun one. Figure out how far out you need to go. How many terms do I have to add until the sum of the first n terms is 279? No, it starts with 3, and then the next one's 10, and then the next one's 17.
Oh, wait, hold on. Come on.
Yeah, no, it is.
Oh, I believe.
Yeah, I mean, you can use whatever you want. What I mean here is the sum of the first n terms is 279. How are you supposed to solve it? With algebra.
Like, I know how, but what am I supposed to say here? Yeah, but like,
You want to do it also? Or do you know how to do this? Kind of like do it, right? But I think you're confused with something.
Oh, no, I never divided by 2. That is quite impressive.
Yeah, so the sum of the first n terms is n over 2.
or is it? Is it
In general.
Hold on. Oh, that.
Yeah.
That's just not my there.
What's the quadratic history?
Alright. Yeah, so once you get that far, now it's just like a hard algebra 1 problem.
Just,
It's basically if I 7 every time, so you just add 3, so you just subtract 3 from 279 and then divide that number by 7.
Well,
It's like,
Does that work?
Why did it work? I mean, it doesn't work if we get a result.
oh my god, my
Wait, how to try to find it?
If I get to it, it's just the number of 7s, right? It's just 3 plus 7n, right?
right?
So 3 plus 7n equals 279.
9.
No, it's definitely quadratic.
agree? I know, put the box away. What?
Why can't you just do 3 plus 7n equals 279?
Because you're not looking for the nth term, you're looking for the sum of the first n terms. This notation, I also said it out loud 3 times, means I am looking for n such that the sum of the first n terms is 279.
Well, I have multiplied it.
Alright, if you do it correctly, you end up with like a mean quadratic. Are you guys kind of where I am? Or like not? Beyond? Alright, and this looks really mean, but here's the thing. Bless you. Unless I wrote this problem wrong, and I didn't, it must factor. Because one of the roots is an integer.
What if it does?
Then it's a bad problem. One of the roots must be an integer, and since these coefficients are all rational, then if one of them is rational, like so is the other one, right? Because they come in conjugate pairs. And so that means like it factors. So like it does factor. It's just you just have to like not be scared of 558. Or you can be a little bit scared. Let's just figure out what the factor pairs of 558 are. Woo! One of them is 2 and 279. You guys know another number that goes into 279?
3.
3, because the sum of the digits is a multiple of 3, and it is in this case, it's 18. Then I can put it through what? How many times does 3 go to 279?
A couple times. 93.
3 goes into 279 times, and so it goes in 93 times. Woo woo! I mean, what is it? 3 and 31. Woo! I've just produced a factor tree, and 31 is prime, so this is actually not too bad. So, is everyone with me? So what are all the possible factor pairs of 558? Okay, 558 and 1, that's not going to be it. 279 and 2, unlikely. What else? Maybe like 3 and something. 3 and 93 times 2, so 186. What's another possibility? 6 and 93 is a possibility.
Got it.
And also 9 and 62 is a possibility. And finally 18 and 31. I think did I miss any? Nope. Does everyone see what I'm doing here? This is just like basic kind of middle school math. You make a factor tree and you look at every 2 possible factors, which multiply to be 558 by like taking the primes like at different times. Okay, now does anyone see how to factor this?
Yeah.
Boom.
Oh, yeah,
Cha-cha, cha-cha. So that gives me, wait. Something around.
Orientation.
Oh, I did it backwards. 63, 60, yup. So 7n, 62, and n, 9. So that must be minus plus. Alright, so n is negative 62 over 7. No, I don't think so. Or 9. 9 is the winner. Woo woo. Okay, good. Who is with me? Alright, you get 0 credit for just adding 7 over and over and over and over again until you eventually hit 279. Not a legitimate method. You remember that means we have to show work. There must be a rational procedure which terminates in the correct answer. Woo, so good. Alright, how are we feeling about arithmetic sequences? Good? Can I have this homework just so we have some like points and stuff? And then put it on the table over there next to Ichi underneath the glue. And then we're going to do something else. Oh, you wrote your notes on it. Sorry, you don't need those notes. Just like you guys up here. Good.
Monday.
Should we like type the homework?
What?
What was wait?
Page 674. Yo.
So you got also I did a homework problem.
Did I make a
minus
mistake?
1 times d, but like
Yeah.
when you plug in like 3 for that, it's like I got 7 and minus 4.
I had like solid.
Like for
Yeah, but at what?
7 times 1 minus 4 for the and
Where are we putting it?
If you plug in 1, you mean?
yeah, because I did.
If you plug in 1 for n, then you literally just get a, which is 3.
Wait, where are we turning? Oh, no, because I had done like I must have plugged something in wrong.
Yeah, but so but that would then a is that's 9, that's 9. Yeah, I think the formula you're thinking of is n over 2 times a1 plus a n. So you have to add the a1 in there. All right, how are we doing? Is that thing still recording? You're gonna move over there now? Okay, good. Are you ready for the next? Did you all hand in your homework? You're supposed to be putting it over there next to Techno underneath the glue. Good. Table captions, like, go do that.
What is it?
You know it. If you are one, you'll know. All right. Good. You have to ask, then you're not table captain. All right. What's the other thing that students are learning in Algebra 2 classes all across the country? Geometric sequences. Woo!
Ain't that interesting?
One step up, man. What are geometric sequences? I mean, you guys just like know? This is kind of just like some of this is just like basic. You just like multiply by a number every single time now. For example, yeah, like 5, 15, 45, like 135, etc. This sequence we say is geometric. And the reason it's geometric is because each time we are just multiplying by 3. And just like with arithmetic sequences, we had like a kind of a better, more precise definition, which is that a sequence is arithmetic if the difference between a term and the term before it is always a constant. So for a geometric sequence, it's also possible to say what a geometric sequence is, and well, what is it? Yeah, Daphne.
Look at the differences, and then there should be a constant between the differences. Like between the differences.
No, this is unrelated. This is even simpler. Yeah.
The quotient between the term and the term behind it should be.
Yeah. Definition of a geometric sequence is that the ratio between any term and the previous term is the same, right? So just like notice that 15 over 5 is the same as 45 over 15 is the same as 135 over 45. Okay, so this is just a more precise way of saying what a geometric sequence is. It's any sequence in which the ratio between a term and the previous term is constant. And we have a name for that thing. We call it the common ratio. Just like we call D the common difference. Okay, good. Well, if I'm taking a closer look at this sequence and we want to describe it, instead of just like saying dot dot dot, we can sort of define this sequence or describe it by giving a rule for it. And again, we can do this recursively, or we can do it explicitly. Good. So, all right, the recursive one is like a little bit silly, but I guess we should just do it anyway. How would you describe this thing recursively? Yeah, what are you doing every time? 3. And you just multiply the term before it by 3, right? So, if you need a term, you just take the previous term and you multiply by 3. So any term, a sub n, is just 3 times the previous term. Cool? And then you also need to tell me where to start, because that's not... a sub 1 is 5. Good. So if the first term is 5 and the nth term is just 3 times the previous term. Cool? Okay, but it is also possible to... Yes? Yeah, good. It's also possible to write an explicit formula for the nth term. What is it?
5 times 3 and 3 2b and minus 1.
Yeah, Joseph is observing, look, let's check this out, right? First term, just a 5. The next term is 5 times 3. The next term is 5 times 3 times 3. The next term is 5 times 3 times 3 times 3. So every one of these numbers is just 5 and a bunch of 3's. How many 3's? Well, it depends on how far out you go. If you're on the second term, you've multiplied by 3 once. If you're on the third term, you've multiplied by 3 twice, etc., etc. So if I'm on the nth term, how many times have I multiplied by 3? N minus 1 times. So, cool. Okay, and more generally, if you give me a sort of generic geometric sequence, which looks like, well, the first term we could just call A, the next term would be AR, next term AR squared, AR cubed, etc. And they go all the way out to the nth term. What does the nth term look like? A times R to the n minus 1. So that's the nth term. All right, how are we doing? Okay, good. So we really only have perfect time. We have only really one thing left to do today, and that is we have to derive a formula for the sum of the first n terms. Let's go. So begin immediately.
Some of us actually do the homework. I don't know why
I mean, I was being like,
Yeah, but no one's
I don't want to take this.
I don't.
But we're just separate. Oh my god, stop talking.
Also, some of you may have seen Drew. Have you seen this before? So identify yourselves and take yourself out of the. No, you're just writing some stuff and hoping for the best. You like know this because like math team and stuff. What? You like know this? Yeah.
I don't know how to do this.
Okay, sorry. Oh, you can do some stuff.
Oh, yeah.
You. Sorry.
But it is.
Wait, Sam.
Okay, you have been passed. You got passed.
Oh,
Thank you.
Thank you. Oh, this is how I feel.
Not that much. I'm going up quiz. And you did pages 4, 5, and equalities packet, which is kind of hard. That's pretty much it, right? Alright, so what is this going to be, just to be clear, this is going to be in terms of what? Well, yeah. Of course, there's going to be an A in there. There's also going to be an R in this formula. Once you tell me what A and R, once you give me A and R, you've characterized the geometric sequence. And then you also need to tell me how far out to go, which is N. So you were looking for a formula that has A's, R's, and N's in it.
Yes, well,
Yeah, like you put them in pairs.
I don't think like three.
Why are you scoring there?
Yeah, I have no idea how to try that.
What is the nth term? Is
Oh, wait,
A,
yeah.
R.
I mean, because there's an A in every term, just take the I was multiplying instead of that.
big one.
Alright, so I haven't done anything useful, but I just wrote out, like, that's what I'm trying to do, right? Is what's up on the board right there.
Yeah.
So your goal is to somehow condense that sum with all those dots into, like, a single formula.
Follow.
Try for something.
Oh, it does not work.
One recursive definition is not good.
I like don't even know how to go about just like where to start. Well, you know, like the addition thing, we found like the way to like combine them so that everything's like equal, so like calculating. Right. So you need to do that for like, can you do that?
Alright, so I saw some of you were trying, like, the Gauss method. That's like what you were doing, right? But it doesn't work, right? Or it doesn't work? Yeah, it doesn't work. Josie was trying the Gauss method of writing them all backwards. You can do that, but like what you get is just like a bunch of junk. Because then now when you add the columns, they're not all the same anymore. Because it's not true that they're going up by some fixed amount and down by some fixed amount. So we need to do something more bold. Alright, fortunately we have 15 minutes, and I got a lot of ideas. One idea is that I just mindlessly tell you this little trick which just solves the problem in like 2 minutes. Let's not do that, that's not fun. I have 2 other ideas. Idea 2, yeah, they're just not, you just add them, it's just not true that's like not algebra. Good.
Oh wait, yeah, because you have.
Alright, so this teacher friend of mine made this handout, and this handout contains hints.
Oh, that's the one.
Okay? So, take one of these, what's up? Think you got it? Yeah. The roomie figured it out.
Too much fun in that.
Wait, something like that. Wait, hold on. Gotta go. Take a lead.
Oh, you get like all the.
Focusing in
I don't know when he tells me I'll get it.
Like before we got
So what you see here is like not much. It just has in a using a lot of white space for some kind of reason format. The sums. Oh, also, are you guys feeling it that the A is kind of like not like an issue? The A is like kind of not a thing because you can just factor out the A and then like who cares or whatever. So really, this boils down to what is 1 plus r squared plus all the way up to r to the n minus 1. So, alright, so this guy who made this worksheet said, I don't know man, this seems hard. Let me just do like a first couple and like see if I can figure out the pattern. Alright, the sum of the first 1 terms is just 1. The sum of the first 2 terms is r plus 1. The sum of the first 3 terms is, and then etc. Alright, from this chart, which doesn't really particularly do anything except write things out in a nice organized way, see if you can figure out what the relationship is between the sum of the first 4 terms and the sum of the first 5 terms. Well, on the back is kind of a hint. But it's like an obscure hint. Let's show the people at home. Ugh, this is terrible.
No, you solve for a different. Well, you solve for some.
But you don't know
all the
either
of
of
our.
those in the formula, so that's
You solve for this sum.
You just
That is another. That is another sum. That's the sum of r to the x, starting at x equals 0 and x.
I mean, like,
You would have to solve for that.
No, like, you know what I mean?
When you expand it all out, and I would just get the wrong.
Alright, what do you got? What is one relationship between the sum of the first 4 terms and the sum of the first 5 terms? It's just like staring you right in the face. One of them, yeah.
It's the sum of the first 5 terms is greater than the sum of the first 4.
No, not greater than like an equal. Like what is yeah.
S sum 4 plus r to the 4th equals s sum 5.
Yeah, okay, that seems like pretty much straightforward. He's like, dude, one relationship between the sum of the first 4 and the sum of the first 5 is if I just take the sum of the first 4 and add r to the 4th, then I will get the sum of the first 5. That's pretty uncontroversial. Okay, is there yet another relationship between S4 and S5? Yeah, Sam.
RS4 plus 1 equals S5.
Almost.